Hi everyone, this is Binchen Zhao, and in this presentation, I'm going to introduce you to our work, Incremental Generalized Category Discovery. So what is category discovery? In supervised learning, you are given a labeled dataset and you need to learn classify. But in generalized category discovery, you are also given an unlabeled dataset which may contain old categories you have seen in the labeled data, but also novel categories you have never seen before. So your goal is to learn classifiers that can not only classify the old categories, but also be able to recognize the new concepts. In incremental generalized category discovery, you not only need to do discovery in one stage, but also in multiple stages. So incremental learning, in traditional supervised learning, you're just given a labeled data set and train a model on that. But in incremental learning, you are given a sequence of stages which contains data set at each stage. You need to learn a model to classify those categories. Previous stages data set will be discarded when you are entering a new stage. And in incremental generalized category, in each stage you not only have a labeled dataset, but also an unlabeled dataset which you need to perform discovery on. This setting is motivated by the real-world community of analysts, which aims to collect wildlife observations across time and space across the globe. Here each pair of images are showed. They are the same category but appears in different locations around the globe. You can see they have appearance change. They added more challenges to the analysis data. So to summarize, the challenges in incremental generalized category discovery are twofold. First, novel category discovery. At each stage, we need to discover the disappeared new categories, and also we need to prevent the forgetting of old categories. We propose a method for these challenges. So the core idea is this density selection. We use the KNN graph density to identify the highly confident or highly important examples from the dataset. This can help us identify novel concepts and discover novel categories in the unlabeled data. And secondly, we use the density selection to maintain a support set S with examples from all categories. We use softmax similarity to assign labels. And we train this classifier using the self-labeling loss and supervised losses from symmetricity. The overall framework is using the density selection to select examples and using the soft nearest neighbor classifier to perform classifier learning. And in each stage, we save the density picks to a replay buffer, which will be replayed at later stages to prevent forgetting. So in terms of the experiment, we show that our model performs on par with current best models for category discovery. However, when it comes to forgetting performance, our model shows less forgetting on old categories. So additionally, due to the fine-grained nature of analysis, our benchmark is a harder challenge even for clipper-trained models. You can see more results and experiments in our paper. To summarize, in this paper, we are proposing a real-world setting that challenges the model to recognize novel categories and avoid forgetting of old categories. And a new dataset is built on analysis data, which contains real-world geolocation shifts and real-world category distributions. We're proposing a new method for IGCD, which uses density selection for recognizing novel categories and a non-patriomatic soft nearest neighbor classifier for enhanced representation learning. Thanks for watching. You can access our code and website from this QR code.